So like I said, you're just going to do the first box on your own. All right, guys, so I wanted to start with just the hypotheses, the definition of our parameters, and the name of the procedure. Were we close there? And since, no? Yes, maybe so? Did we know we needed hypotheses? Yeah. Okay. And then, do we see that we have two groups here? So that's why we have one about each one. And then, so we're subtracting, and I just use a subscript of A and P for aspirin and placebo. And then I define those two groups. Are we good with the less than sign? Because if the aspirin's reducing the rate, aspirin minus placebo should be negative. And then I thought we would go through and check our assumptions together. So, what's the first assumption we need to check? Random. Is that met?
Yeah.
How is it met? We were given randomly assigned treatments. Cool. Mountain Dew time.
I have not bought Mountain Dew this whole week, so I'm now doing water like I should be.
Lame.
Oh, but if I don't have it, then I won't drink it, and it's better that I don't.
It's better that you don't drink the water?
No, it's better that I don't drink Mountain Dew. I could do my Crystal Light.
Hey guys, can we do the normal calculations yet? All right, so we're going to find our p hats for each group. So let's see, 15
over 50 and 26 over 50. Or no.
15 out of 500. And 26 out of 500. Guys, I don't know what those are.
It would be 0.03 and 0.052.
Huh?
0.052
For the first one?
no, for placebo.
And then for the aspirin?
0.03.
Thank you. 0.03 what? It was 0.03 even? Right on. Okay. Oh, duh. Okay, cool. Let's pretend Miss Meister knows a few things, okay? All right. And so now can we do our normal condition?
Yes.
Now, this is the one time we have to use that stupid combined thing. So I'm going to add my samples together to make one giant sample. Another way of saying this, guys, is we're essentially saying that the 41 people who had who developed colon cancer, okay, they were going to do that with no matter which treatment group. So really, this is just one giant sample, and that it happens because we're assuming that null hypothesis is true. Okay, so now we're going to do 500 times, I think this is 0.041. 500 times 0.041, 500 times 0.939, no, thank you. And then theoretically, you should actually write that twice, once for each sample, which is super annoying, I know, but you only have to do the calculation once. And I'm thinking 20.5, 20.5, so that's good. And then I just want to point out, we have not fully checked the normal condition by coming up with those numbers. Is the normal condition met? Yeah, how do I know that? Yeah, we need to show that we know those numbers are greater than 10 and that's the important, like that's what we're looking for with those numbers. Okay, cool. Independent?
There's more than 1,000 people with colon cancer.
No.
I can't remember the thing. Responses are independent.
In this case, what you're going to say is individual responses to the medications are independent. All right, next, I want you guys to do the calculations for that top right box for me.
What thing is calculator? I know it's in the stat test, but which one is it?
I don't know. Here's the deal. The way you make that decision is you say we're doing 2 sample z-test for a difference in proportions. So it's got to have a 2 in it, it's got to have proportions in it, and it's got to have a test in it. Jackson, it's not that I don't want to tell you, it's that I want you to have that problem-solving process for when you're taking the test, and I won't tell you.
And it would be less than, right? Because
It's going to match whatever the alternative hypothesis says. Everybody good? Almost done? What's the last step?
Click on the, right.
Write the conclusion. All right, so we're going to say something along the lines of, since 0.04 is less than does it, oh, they told us alpha equals 0.05. So we can reject the null. Therefore, we can conclude, and this is going to be a little bit trickier. Can we conclude cause and effect?
Yes. No.
I think you need to pick one, Bub. What's necessary to conclude cause and effect? We need to have an experiment with randomly assigned treatments. Do we have that? Okay. Can we conclude it about everybody?
No, they're volunteers.
No, because we have volunteers, we can only conclude about people similar to those in the sample. So we're going to say we can conclude that aspirin lowers the risk of heart attack for people such as the volunteers in this study, or similar to the volunteers for the study.